Students, today we will learn about decision making and branching statements. This is also known as selection statements. Normally, a program works line by line, the first line, second line, third line, fourth line, etc. But sometimes we may need to switch from one line to some other code. In that case, we can use decision making statements. We are deciding whether to execute the next statement or the fifth statement or seventh statement like that. Such types of statements are known as decision-making statements or branching statements. These are the decision-making statements available in C, if statement, switch statement, condition operator statement, and go-to statement. This is the syntax for if. We test an expression. If it is true, a set of statement blocks will be executed. Look at the example. If A less than B, printf A is lower than B. So this is if as a keyword, and after that we are setting a condition and then a curly bracket. If is a keyword, this is the condition, and we have the curly bracket. Inside the curly bracket we write a set of statements. We close this curly bracket too. If you have more than one statement, this curly bracket is compulsory, otherwise we can omit that. Okay, this is a condition for where there is else part also. We can write only if or if with else. As if this condition is true, this statement blocks will be executed. Otherwise, this statement block will be executed. For example, if A less than B, we print A is lower than B. Otherwise, we print B is lower than A. This else is part is also optional. We needn't write it always. This is optional. Okay. And look at this one here. This is a flowchart diagram for if part. If test expression. If it is true, statement block A will be executed, and we come to the next statement. If it is false, we straight come to the next statement. This statement block A will be A is omitted. We make a decision. That is, if the test expression is true, we make a decision to execute whether statement block A should be executed or not. Okay. Look at here. Here, if we test this condition, if it is true, statement block A will be executed. Otherwise, statement block B will be executed. Both statements. We are giving two different set of statements for based on the condition. If this condition is true, this will be executed. Otherwise, this one will be executed. Anyway, we go to the next statement. Now see a program, a small program to demonstrate the working of if-else using a condition. We are going to evaluate a plus b divided by c minus d. This expression works only if c minus d is not equal to 0. We are not allowed to divide by 0. Divide by 0 produces infinity. We are going to eliminate that condition. If c minus d is 0, we are not going to evaluate a plus b by c minus d. Or in other words, we are going to evaluate a plus b by c minus d only if c minus d is not 0. This is a condition. You know how to write a command. We are writing command, a program to read values of a, b, c and evaluate a plus b by c minus d if c minus d is not 0. Okay. First, we have to include the stdio statement. Why is this needed? Because we are using printf and scanf. Then void main. This our main function does not return anything, so we are using void main. And we are reading a, b, c, d. We are setting this as floating point number and set the answer. We are initialize the answer as 0. Okay, actually this is not necessary. This is to this way we can set the value 0 to answer. Then printf enter the values of a, b, c and d. We have declared this as floating point number, so we have to write percentage f here. This is a floating point number, so this also is percentage f. Okay, and a and b and c and d. Look, there is no space in between. Starting with double quote to double quote, we can write percentage f without any space. This is very important. You should not write any space here. Space has a different meaning. Space means it is expecting a space from the keyboard. So we are not writing any space here. So you must write this without any spaces. Then and is also compulsory because we have to write the address of A, address of B, address of C, address of D. And every statement ends with a semicolon. Now we are checking if c minus d is not 0, find out answer is equal to a plus b divided by c minus d. And we are printing the answer as answer is percentage of ans. Okay. Else print up the denominator is 0. So what you are expect, what answer you are expecting? You will be getting a plus b by c minus d if c minus d is not 0. Otherwise, you will get this statement. The denominator is 0. See how it works. This is a command when you are writing in an interface. We have written without any spaces, checking whether d minus c minus d is not equal to 0, evaluating this. We have two statements here, so this bracket is compulsory. Here there is only one statement, so bracket is omitted. This is output. We are giving the values 1, 2, 3, 4. So the answer will be a plus b divided by c minus d. A plus b is equal to 3. C minus d is minus 1. So answer is minus 3. What is here? 4 minus 5 is minus 1 by 0. So no, we are not evaluating this. We are first checking whether c minus d is equal to 0. Here c minus d is 0. So we print denominator is 0. Now look at this one. In this case, we find out the values of a, b, c, d. 3 minus 2 is 1. And 5 minus 1 is equal to 4. First we are checking whether c minus d is not 0. C minus d is not 0. 5 minus 1 equal to 4. So we are calculating 1 by 4. 1 by 4. 1 by 4 is equal to 1.250000, etc. So we are getting this answer. Now we check whether there is only else clause in a statement. If condition 1 is true, we are executing statement 1. Else if condition 2 is true, we are executing statement 2. Else if condition 3 is true, statement 3 is executed. Like that, only else if statements. You see how can we write the flowchart for this. First we have an entry clause. If it is true, one statement. False, we check another condition. If it is true, second statement. False, check another condition. Again, true, statement 3. False, another condition. Like that it goes. This is known as else if ladder. Looks like a ladder. See, this looks like a ladder. So this is known as an else if ladder. And finally, we are supplying a default statement. If nothing is true, do a default statement. And after statement 1, next statement is executed. After statement 2, next statement is executed. After statement 3, next statement is executed, and so on. Okay, look at that code. Here, if test condition 1 is true, again test condition true checked, condition 2 is checked. If both are true, statement 1 is executed. If first is true and second is false, statement 2 is executed. If first is false, statement 3 is executed. In all cases, statement 4 is also executed. Okay. See how can we write the flowchart. First check test condition 1. If it is true, we go to test condition true. If it is true, statement 1 is executed. Okay. Otherwise, statement 2 is executed. Again, if first condition is false, statement 3 is executed. And all those comes to statement 4. So this is the flowchart for this code. Okay, these are some of the other conditions. We can nestlist any way which we want. We test condition 1. Again, if condition 2, statement 1. Else if condition 3, statement 2. Else condition 3, statement 3, like that. Always the else is combined with the nearest if. See, if here all the brackets are omitted because we have only one statement. If condition 1, condition 2, statement 1. When will the statement 1 will be executed? Statement will be executed if first one is true and second one is true. What about statement 2? First condition should be true and second should be false. What about statement 3? The first condition is false. Look at here. Condition 1, statement 1. So this is executed if first condition is true. Else if condition 2, that is first is true, second is true, statement 2 is executed. Or what about statement 3? When will statement 3 will be executed? Okay, so there's a confusion here whether we have to assign else with this if or this if. There's only one else here, so we should know to which if we have to associate this else. Else is always associated with the nearest if. So this is the else of this. We can write it anywhere we want, but always this else is associated with this if. So this statement 3 is executed when condition 1, that is condition 1 is true. I'm sorry, here condition 1 is false. Literal once again. If condition 1 is true, statement 1 will be executed. This is else. Else if condition 2 is true, that is condition 1 is false, 2 is true, statement 2 is executed. Statement 3 will be executed only when else of this, that is condition 1 is false, condition 1 is false, that means we come here. Again this is false. Yeah. Condition 1 is false and 2 is false, statement 3 is executed. Okay, now see a small program to find the maximum among three numbers. We have numbers A, B, C and we have to check which one is maximum. So first we compare A and B, take the maximum among that and compare that number with C. That is, first we compare A and B. If A is greater than B, answer is A here. A is a bigger among this. So we compare A and C. We compare A and C. If A is greater than C, answer is A, otherwise C. Similarly, else of this means B is greater. We compare B and C. Again, if B is greater than C, answer is B, otherwise answer is C. See the code for this. First we write the comment. It is better to write comment at the beginning of each program. That gives you more readability. It's to study when you are doing your exam. Then next we have to include stdio.h void main in ABC max. That is A, B, C are for reading the three numbers and max will store the maximum. Enter the three numbers. We are reading percentage D because this is integer. Percentage D, percentage D, percentage D and A and B and C. Now we are first comparing A and B. If A is greater than B and if A is greater than C, we can write max equal to A. Else max equal to C. Else of this means B is greater than A. In that case, we compare B and C, max equal to B, otherwise max equal to C. The maximum among three numbers are printed. A, B, C is max. We have written a set of if-else statements. We can combine this using and, or, etc. We'll cover it later because this is for simplicity. We compare two numbers, again check if nested if, etc. We can write in one statement using logical and or. And we can try that. This is a code and this is the output. Here we are giving three numbers, the maximum is 3. Now we are giving three numbers, maximum is 3. Why do we check lot of statements? You have to carefully choose the input to get the output. That is, look at this one here. Which is the I have given 1, 2 and 3. The maximum is 3. The last number is maximum. You got the answer correctly. Now giving the same thing with first number as maximum. Then also we get the answer correctly. Now we are giving the middle number as the maximum. You got the correct answer. So in this case, this is the highest, this is the second highest, and this is the third highest. Now just interchange those two. This is the maximum, this is the second highest, and this is the third highest. This is the third one. So here also we got the maximum. Why do we do all these things? Because we want to ensure that our program works for all possible loops. Works for this one, works for this one, works for this one, and works for this one. Ensure that your program works for all possible combinations. Okay. This is the next program. A program to compute electricity bill. An electrical distribution company is there. Their charges its domestic customers as follows. If the unit consumed is 0 to 200, only 50 paisa per unit is consumed. Is the rate. If the charge is from 201 to 400, 100 plus 0.65 per unit excess of 200. Okay. To the amount which exceeds 200, they have to pay 0.65 plus altogether 100. For 401 to 600, the amount is 230 plus 0.80 per unit excess of 400. For 600 and above, the amount is 390 plus rupees 1 per unit excess of 600. This is the code. We have declared in the unit and consumer number. In units and consumer number. Floating point number charges can be floating point number that like 2.5 etc. So that is given in float. Read the number, consumer number, a unit of electricity consumed using percentage D. Unit is 200, 300 etc. So units is given as integers. Okay, if unit is less than 200, charges is 0.5 into unit. If it is less than 400, 100 plus 0.65 into units minus 200. Similarly, it is less than equal to 600. The charges will be 230 plus 0.80 into units minus 400. Otherwise, that means if the amount is greater than 600, what you have to do? It will be 390 plus units minus 200. And we are printing consumer number percentage D has charges equal to 0.2f consumer number and charges. Why 0.2f here? We want our output to be 2 decimal point. 0.2 decimal points. That's why we explicitly said 0.2f if it is a floating number. So this is the code and this is the output. For 2 and 200, the charges is 100.00. Why this 0.00? We have written 0.2f there. That's why 0.00 comes here. For everywhere 0.00, 0.02 like that. Okay. This is the output 300. We get the answer 165. For 400, the answer will be 230. For 500, the answer will be 310. For 600, the answer will be 390. 601, the answer will be 391. Check all possible combinations. First, you work on whether you are getting the correct answer and verify your answers. Okay. The next type of decision statement is switch statement. Instead of writing a set of if-else statement, we can write a switch statement. Okay. Switch expression case value 1 statement block 1 break, case value 2 statement block 2 break, etc. Default statement default block break. This is the syntax. Okay. See here, what this means that case this same as if expression is equal to value 1 execute statement block. Else if expression equal to value 2 execute set of statements. Instead of writing a set of nested if, we can write in a more good way using switch statement. One of the difference between if else and switch is that in if we can do if expression less than value 1. We can write this is valid, but we cannot write here. Here expression must take either value 1, value 2, etc. Okay, expression the value of expression should be either value 1 or value 2 or value 3, etc. We can write a default statement that will be good for any default value, but explicitly we need a value for each cases. Let's see an example. This is a flowchart for if else statement, switch statement. Here, if the switch expression is true, we are checking the switch expression. If expression is equal to value 1, then execute statement block 1. If expression is equal to value 2, statement block 2. Expression is equal to value n, statement block n. Otherwise, default block will be executed. After the end of each one, we come to the next statement. Okay. I forgot to mention the break value. Here we have a break. Why do we need this break? Break is used to come out of loop. If we execute this break statement, our control will come to this way, out of this block. If we omit this break statement, what will happen? We execute statement block 1, statement block 2 until we see a break. So break is necessary to come out of this loop. Okay, this is a program to grade the students based on marks. Here we are giving the mark out of 100. Calculate the index of the mark. The index of the mark is calculated by dividing the mark by 10. So what will happen here? Suppose we have a mark 87. When we divide 87 by 10 using integer division, the answer will be 8. So this statement is enough to convert the mark from 0 to 100, 0 to 10. See, if the mark is 78, 75 by 10 will be 7. In the case of int, we have to declare this as int itself. If mark is 99, the index will be 9. So, if you have a mark out of 100, from 0 to 100, the index will be 0 to 10. Okay. Now, you check whether index equal to 10, 9 or 8. The grade is equal to A. 7 or 6 grade will be B, 5 grade C, and 4 grade D, 3 grade E, and 0, 1, 2 grade F. Okay. See the program. A program to find the grade of a student. Hash include stdio.h for because we have printf and scanf statements here. Void main because the program does not return anything. Float mark, int index, character grade. This is for printing a character A, B, C, D, etc. See, these are all character constant. So you must know, you should not write like this. This is wrong. You have to use single quotes. This must be declared int because we want integer value. Now we read the mark of a student out of 100. Scanf using percentage of and mark. Index equal to mark by 10. Then switch index. This index can take value 0 to 10. If it is 10, what you have to do? You have to print grade A. If it is 9, grade A. If it is 8, grade B. If it is 7, grade B. 6, grade B. 5, grade C. 4, grade D. 3, grade E. And default is grade F. And break. We need a break at the end of each case because after printing grade A, we do not want to print grade A, B, B, etc. We do not want to go through other case statements. That's why this break is written here. Okay. And finally, the switch is closed here. We print the grade as grade, percentage C grade. Okay. Now, the problem with this is that here we have an A grade, here also we have an A grade. The same statement is repeated twice. Here this statement is repeated thrice. So we can avoid this using another way. In the case of case 10, just leave it there. Write case 9, grade equal to A. And write a break. Semicolon is there. So what happened? When you see grade 10, nothing will be executed. Automatically it will go to case 9. Okay. Similarly, here also there is no break here, so automatically go to this one. Similarly, here also we can write case 8, case 7, case 6, grade B break. This is the output. We give a mark out of 100. Given 98, grade is A. When you are given 20, the grade is F. When we are given 68, the grade is B. 53, grade is C. And 45, the grade is D. Okay, now we are going to check another program. We are going to check whether a number is even or odd. How do you find that a number is odd or even? We know that 8, 56, 34, 16 are all even numbers. So how will you make a program to check whether this is odd or even? The best way is to divide this by 2. Find out the remainder. If the remainder is 0, the number is even. Okay. Because it is an even number, it will be divisible by 2. So we divide this number by 2. That is 4. What's the remainder? Remainder is 0. So how do we find this? We are using this percentage operator. We are dividing 8 percentage 2, it will be 0. 56 percentage 2, it will be 0. So if for any even number, the remainder is 0. Similarly, for any odd number, the remainder is 1. So in our program, we are just checking the remainder. If this remainder is 0, our number is even. Otherwise, our number is odd. See, this is a statement. First, we write a command, then write the include statement, integer number, enter a number, scanf percentage and number. If number equal to 0, the number is even. Otherwise, the number is odd. We can also write in a different way. Here we can check whether we can write the statement if number percentage 2 equal to 1. So in that case, first what you do? First you have to print odd. Yes, you have to print even. It's also possible. We can write the condition in many different ways. We can also write it like this. If not number percentage 2 equal to 0. What does it mean? Not number percentage 2 equal to 0. This is for even. For not means this is for odd. We can give or check in many different ways. This is output. We are giving 45, get output odd. 78, output even. 35, output odd. Okay. Now this is a program that you have to work out as an exercise. First you have to check a number whether it is divisible by 5 or 6 or both. How do we check whether number is divisible by 5? Whether check n percentage 5 is equal to 0. Similarly, n percentage 6 equal to 0. You get the number divisible by 5 or 6. We can combine these two using AND operator. Okay, check it. Write the program. Second program is to find out the area and nature of a triangle. Okay, how do we check the area and nature of a triangle? We know that the triangle has three sides ABC. And there is a fundamental theorem that sum of the length of any two sides must be greater than the third side. That is, suppose we have a triangle like this. The three sides ABC, A, B and C. A plus B should be greater than C. Okay. Similarly, A plus C should be greater than B and B plus C should be greater than A. This is a fundamental theorem for making a triangle. Okay. For example, suppose you have two sides 3, 2, 5. Let me 6. Yeah. Suppose you have 2, 2, 2. 2 plus 2 is equal to 4. 4 is greater than 2. This makes a triangle. Suppose you have minus 2, 2, 2. This is 0. 0 is not greater than 2. This is not a triangle. Okay. Another condition is that we have to check whether the triangle is equilateral. Equilateral means both sides, all the sides are equal. We check whether A equal to B equal to C. If it is true, it's an equilateral triangle. For isosceles triangle, any two sides are equal. A equal to B or B equal to C or C equal to A. Check whether you have to write equal to because we are comparing two sides. If you write B equal to C, what will happen? The value of C will be assigned to B. It's not so. We have to compare B and C. Otherwise, if a triangle has only three sides, either it should be all the sides are equal or two sides are equal. Otherwise, what will happen? It is a scalene triangle. Okay. Now, how do we find the area of a triangle? The formula is square root of s into s minus a into s minus b into s minus c. We have to convert this logical expression into c expression. How do you convert this? We use SQRT area equal to SQRT of S star S minus A. We need an expression between every operand. S minus B star S minus C. Okay. Put a semicolon. Since we are using SQRT, which one you should include? You have to include, you have to use hash include math.h. This you have to include. Now, how do you find out S? S is equal to A plus B plus C divided by 2. These things are required to write the program. Write the program on your own. We'll check the answer in the next class. Another question is find the roots of a quadratic equation. You know that a quadratic equation has two roots. The roots can be real and distinct if b square minus 4ac is greater than 0. Suppose your equation is ax square plus bx plus c equals 0. The roots are minus b plus or minus square root of b square minus 4ac by 2a. Okay. If this one is greater than 0, you will get two roots. Minus b plus this value and minus b minus this value. You get two roots. Roots are equal if b square minus 4ac is 0 because we will get minus b plus or minus 0. So this term is not there. That's what there will be only one root, equal roots. Similarly, b square minus 4ac is less than 0. What will happen? It will become a complex roots. So this program can be written using if-else statement. Compare the values of b square minus 4ac each case and find out the roots using this formula. Thank you.